YouTube! Welcome to another video! Today we're watching our little 20,000 watt microwave oven by styropyro. Let's go! Let's get into it!
So hear me out. A typical microwave oven is about 1,000 watts. Well, I'm wondering what kind of fun could be had with an oven that's 20 times stronger.
Uh-oh.
Now I'm sure many of you have wondered this as well. But if not, there are a few things that a 20,000 watt microwave would accomplish.
I'm gonna be honest, I have never thought about it. Personally, I have never thought about it, but I don't know. Microwaves, maybe you can actually make crispy food in the microwave if it's like that many watts.
Now the obvious one is cooking food faster. I mean, in this day and age, I shouldn't have to wait minutes to cook a Hot Pocket. Oh no, this should take seconds. Microwave experiment should be 20 times more
Why do you have a banana in his hand?
exciting as well. I mean, even an oven like this is capable of some cool tricks. So I'm hoping that throwing obscene powers at these classic demos will give some fun surprises. And this brings up...
What? I've never watched a video of him. Is he okay?
my last point. The plasmas that could be made would be hellish. Like seriously, if you thought plasmas in a normal oven were cool, imagine the kind of witchcraft that you could pull off at extreme power. Is there anything that it wouldn't melt? There's only one way to find out. Let's build a 20,000 watt microwave. So,
let's go.
how do you get 20,000 watts out of a microwave oven? Well, you only need to upgrade two components. Let me open one of these up and show you what I mean.
Ooh.
Now I gotta say it, the power supply in a microwave oven is lethal. In fact, when science hobbyists get killed by their projects, more often than not, it's because they were screwing around with microwave parts like these.
Oh God, don't touch them like that! Oh my God.
Anyway, this right here is what generates the microwave radiation in an oven. It's called a magnetron. Now interestingly, this is actually a vacuum tube.
You guys, this is how I feel whenever I accidentally touch an outlet. Does this sometimes happen to you when you maybe it's dark and you try to find the light switch and then you accidentally touch the outlet a little bit and I get so scared.
Which means unlike phones, TVs, and radios, the main technology in microwaves is the same as it was 70 years ago. Pretty cool, right? So can you just dump more power into this magnetron and get more power out? Well, you can, but only to a point. I've actually tried this, but I only got to a few thousand watts before it blew up.
Banana,
so this
no.
method won't get me to 20 kilowatts. I simply need a bigger magnetron. Now, unfortunately, even though oven magnetrons are a dime a dozen, big ones are really hard to come by.
I'm not gonna lie, magnetron sounds like, it sounds like it doesn't exist. It sounds like a made-up word from like a TV show, from like Jimmy Neutron, trying to sound very, very cool and scientific. But it exists, so, I'll take it. This is how I feel when I disassemble a microwave and handle the components carelessly. I'm sure he's making this with a lot of care.
In fact, I've been waiting for years to make a video like this.
What?
I simply couldn't find a big magnetron. However, my luck finally changed. Enter the Megatron. This water-cooled beast is rated for 16,000 watts of drive power, and I plan on pushing it to 20. It's actually kind of funny that I'm even allowed to own this. Now there's a bit of lore to how I obtained this beast. It was an eBay purchase, but it was not me that found the listing. It was the notorious Discord entity.
I can't believe this. We mentioned this earlier in the stream. This particular place, Come and Go. This was mentioned earlier, 2 hours ago. And now it's coming up again. It's literally coming up again. There's no way! What?
Tarzard wrecked. That tipped me off to some monster magnetrons being sold as heat exchangers.
Made
I bought
in
a few.
Japan. Wait, you can just buy it? Is that AliExpress?
Tipped me off to some monster magnetrons being sold as heat exchangers.
I see. Is this AliExpress? I know AliExpress when I see it. Or Alibaba.
I bought a few, And although one
Oh, eBay, okay.
came DOA, 2 were still functional. I was salty about the dead unit, but then a scorpion jumped out of the package, which I thought was a pretty cool consolation prize. Anyway, what do I do with this now? So can I just jam this thing in there and call it a day? Well, there's one problem with that. It don't fit. I could have just built a bigger waveguide, but I thought back to some of the oldest microwaves that I took apart over the years. And I remembered that some of the oldest ones had big waveguides inside of them. So I picked up this old radar range microwave from the 70s, and I just love how it looks. But to be honest, it's also just built like a tank. Like, they don't make microwaves like they used to. Gosh, this thing weighs like 80 or 90 pounds, I think. So
it looks like it's plastic, but I guess it's not. It's full on metal. That's insane. Thank you for the stitch. Thank you. It's also huge. It's so freaking huge. What the heck?
It's a real beast.
Wait, I think this is... No, actually, never mind. I think my oven, which is not a microwave, it's just kind of like a little oven, I think. I guess it could be called a microwave oven. I don't really know. I don't really know the specific term, okay? But mine is smaller than that, and you're supposed to use it like an oven.
The huge magnetron fits perfectly.
Wait, 40 kilograms? Are you serious? Oh my god.
Inside the oven. But it brings up another issue. How am I going to power it? I need 20 times more power than this thing can provide. So perhaps I can take apart 20 microwaves, chain together the transformers, and power it that way? Nope, that sounds horrible. I have a better solution in mind. I bought this cute distribution transformer that'll be perfect for the job. Now it is technically a bit undersized for the load, but for short runs, it'll be fine.
Why does he have all of that? I'm so confused. He owns so many things, but
All right, it's all wired up now. Let's fire this beast up. Now, before I stick anything crazy in there, I just want to try boiling some water to make sure it actually works.
Hello, Draven.
Now, I will admit that running this thing isn't quite as straightforward as running a household oven. So let me show you the startup sequence. Now, you do have to close the door because there's no safety interlock to prevent you from cooking the room if you leave it open.
Oh my god!
I'm gonna start by firing up this water pump here. So next, I'm gonna go here and fire up the magnetron filament. Next, I'm gonna hit this switch here, which energizes that boosting auto transformer, which then feeds my variac. And now, I'm gonna take my variac and crank it all the way to 100.
Oh my god.
And this switch right here.
Kill box number 2? What do you mean, kill box number 2? Danger, you will die. Danger. Okay.
Finally powers it up. So, let's boil some water. A typical microwave oven takes nearly 2 minutes to bring a cup of water to its boiling point.
Oh!
This one goes beyond that in seconds.
Why does he?
Yes,
Oh,
water
no.
actually explodes because it superheats faster than it can boil. If water explodes in there, imagine what'll happen to things you aren't supposed to microwave. I'm sure you're dying to see how fast food will cook in that thing. But the fact that it makes water explode means I gotta try some of the classic microwave experiments first. So...
Oh no, is he gonna put a spoon in there? Is he gonna put a spoon in there?
let's see what it does to a light bulb.
Okay, I mean, okay. I guess that's just as bad.
What could possibly go wrong?
No.
All right. Here we go.
I'm so scared. Oh my god.
Wow.
Oh my
It's just
gosh.
instantaneous. Oh my gosh. Oh, that's hilarious.
Yeah, it turned on, right? That's kind of crazy.
Look at that.
Yeah, the super villain laugh, actually crazy.
It just
Huh?
turned it into dust. Oh, that is so funny.
Oh my god.
Jeez. By comparison, when I tried this in a normal oven, It took nearly 10 seconds to melt through, and it didn't even come close to exploding.
I didn't know it lights up in like different colors, huh?
Is it a good idea to microwave an egg? Let's find out.
No, it's gotta be so
All right.
messy.
Here we go.
Oh? Ew! Isn't it gonna
Oh my
cook
goodness.
instantly? Oh, it does cook. It did cook a little. Did you see that? Next, let's try this guy. I can't. No. Surely not. Surely not.
An egg in a normal oven as well, and it took over 30 seconds to pop and wasn't nearly as violent. I'm curious what'll happen to a plasma globe inside this thing.
Oh my god. What?
All right. How do I even do this kind of stuff?
Ooh. Oh my god. Whoa!
That was so loud. Oh my gosh. Wow. That was crazy.
Yeah, wizard orb.
Oh my goodness. It's just like powder. Oh, you gotta see this. That was reduced into dust. Into just dust.
Yeah, his laugh is perfect. Oh, I had those gloves and they would make you dizzy when you touch it. Really? I feel like these kind of scare me a little bit. Because you do get like electrified a little, right? When you touch it. Isn't that the thing about them? It's not meant to do that? Oh, okay. I thought it does. Okay, never mind. When you do it for too long. How long are you touching the orb?
Well, there's like, those pieces are so tiny. That's crazy.
Oh my god.
That actually exploded so violently that bits of glass shot holes in the mica waveguide cover. Yikes.
What?
Now, speaking of plasma, the metallic coating on this chip bag should be pretty interesting. Let's activate the shrink ray.
Oh, let's go. Oh. Oh.
Instantly. A lit candle can be crazy in a normal oven, so I figured it'd be worth trying in this thing as well.
Oh my god. Wait, that's so cool. What the fuck? Wait, what? I'm surprised the glass didn't break. Well, I guess it's extra sturdy.
Funny side effect of all that plasma is that it turns the air in there into deadly nitrogen dioxide gas, which gives it that brown color.
Oh.
Now, if you're wondering how I'm filming inside the oven, I just have a hole drilled in the cavity there. And then over here, I just have a cell phone that's just taped to the walls there. Now this works because the hole is pretty small relative to the microwave wavelength, so it doesn't let much radiation out.
What? I'm so surprised that is, I mean, it doesn't look safe, but I'm surprised that works, kinda. Like, what?
Now, I'm not the first YouTuber to use this technique. I think
What?
Cody's Lab was the first to do it on YouTube. But then Nile Red has a good video on microwave plasmas that uses this. And then Steve Mold actually has a whole video about, filming inside a microwave. Anyway, I think it's time we cook some actual food in this thing. And it's funny because after years of doing everything with a microwave that you're not supposed to, I'm finally going to come full circle and use a microwave oven to simply heat some food. Let's start with a Hot Pocket. The instructions say it needs to cook for nearly 3 minutes in a puny home oven.
Oh, I like that it does that. I like how it...
The instructions say
I've never had a Hot Pocket, but I
needs to-
like that it says for crispy crust and for softer crust. Are you guys a crispy or a soft person? I'm definitely a crispy person. That's interesting. Ah.
to cook for nearly 3 minutes in a puny home oven. I'm hoping this macrowave will cook it faster.
Uh-oh.
Well, it didn't explode, but I'm not sure if that's a good thing or a bad thing.
Uh-oh.
Alright, let's take a look.
I don't know, should you eat this? Should you eat this, you guys? I don't know.
Oh yeah, looks done. Oh yeah, it feels done too. Well, there's your 10-second Hot Pocket.
Okay, it's definitely not crispy. Well, I thought it might get crispy in the microwave, because this one's like a hot microwave, okay? So I thought this one, but I guess not. Okay.
Now the most surprising part about this is that it cooked evenly, because I know this oven has some hot spots. I wonder how quickly a hot dog will cook in this thing.
Uh-oh.
I was kind of hoping it would explode, but at least it was cooked in seconds. I actually left it in there way too long, judging by what it looks like afterwards.
What do you mean? Now it looks good. It was way too pink.
I chucked a potato in there without stabbing any holes in it.
Oh, no.
Also with the hope that it would explode.
Oh,
but
no.
Unfortunately, it simply flash cooked like it was supposed to. It did make some funny whistling
no.
sounds though. In fact, a lot of foods make that funny whistle, and pickles turned out to be one of the best noisemakers.
Why would you put a pickle in the microwave?
Let's test another microwave food classic, popcorn.
Oh yes! You think it's gonna work instantly?
This one was
It's
actually
gonna pop
kind of
instantly?
disappointing, because it took 30 seconds to pop fully. Now this is several times faster than a normal oven, but I was hoping it'd be instantaneous.
Yeah.
At least it didn't burn though.
Nice.
Now it's time for everybody's
Nice.
favorite food to microwave, the grape. And you know what? Let me go ahead and cut it almost in half, just to make sure, it heats nice and evenly, Like this. And yeet.
Uh-oh. Wait, why does this happen? Why does the microwave... Wait. Why? Because I've heard about the grape thing before. Plasma.
Unfortunately, the fragrant smell of roasted grape is hidden by the suffocating nitrogen dioxide fumes, which is the deadly brown gas left in the beaker there. Instead of cutting a grape in half, I just tossed in some unmodified grapes to see if I get the same result.
I feel like that's... Oh god. Oh god.
Yep, grapes are haunted. These grape plasmas are incredibly bright, but of particular interest is their
Unmodified
color.
grapes.
They glow white and even have bits of blue coming through. I'm wondering if they're being heated beyond white hot to blue hot.
Ew.
The big brain way to answer this question would be to take a UV visible spectrum, fit it to the Planck radiation law, and determine the temperature that way.
What the FBI sees when they open his front door. I mean, I don't think he's committing any crimes, but it looks like he does. You know what I mean? It looks suspicious, because why does he have all that stuff?
But you know what? That doesn't sound nearly as fun as chucking a bunch of metal in there and seeing what kind of hell is unleashed.
No.
So yeah, let's do that. Let's see if the microwave can melt magnesium ribbon, or at least see what kind of plasma it'll make.
Oh my god. Oh my, is it melting? Is it melting?
Not only did it melt and burn in there, but it also managed to show off some of its green spectral
Whoa.
colors, which is in contrast to the white you get by simply burning it in air. Aluminum melts at only slightly higher temperatures than magnesium, but for the sake of curiosity, I'm going to toss some foil in there anyway. Alright, here goes nothing.
You know, I'm mostly surprised that the microwave itself is holding up so well, but I guess that's what I'm,
Now
you know, it's because it's full metal. it's too tough.
is like an arc furnace. Oh my goodness. Now it's time for something more challenging.
Oh, he once said that one time the police actually showed up, but nothing crazy. They just wanted to make sure he does nothing illegal. I mean, yeah, that's what I'm saying. I feel like it looks like he would do something illegal. It looks like he's yeah. Oh no.
Needs to be very hot before it melts.
Oh,
So now it's time for something more challenging. Copper needs to be very hot before it melts. So let's see how it holds up in the microwave.
Oh, damn.
Yeah. It melted almost instantly. Now this also brings up an important point about the glass.
Oh! Oh.
It's actually astonishing how well these Pyrex beakers have held up to the plasma.
I was gonna say, at least finally the thing below broke. Crazy that the glass is that, strong. Or was, I guess.
The same cannot be said about this Pyrex bakeware. The difference is that the beakers are made from borosilicate glass, which has very low thermal expansion. Pyrex bakeware used to be made from this as well, but has since been changed to tempered float glass, and its internal stress patterns are easy to see in a polariscope. This change is unfortunate for home science, but it does make for less dangerous breaks in the kitchen, as it tends to explode into tiny bits as opposed to razor shards. Anyway, let's move up the temperature scale to some thermite.
I mean, to be fair, most people will never get it to break, probably. Right? Most people, it should not break.
Thermite is so hard to ignite that you can buy it pre-mixed and have it shipped to you without crazy restrictions. I'm hoping this microwave can achieve its high ignition point. Yeet!
Yeet! Chew, chew! Oh my god! Oh.
Huh, so that's what it took to break one of those beakers. It basically just exploded in there. All the iron product is dispersed in little droplets. That was fun. Although
That was fun. Okay. I don't know. I would be pissed to clean up all of that. Oh my god. Yeah, right. It's how he said it.
although that reaction made molten iron, it was kind of cheating due to all the chemical energy released. Let's try directly melting some iron in the form of steel wool.
Oh my god. Whoa! Well, that's easy. Look at that.
Yep, no problem there. Next on the list is titanium. This stuff is quite hard to melt, but I think the microwave can pull it off.
Okay, fun fact, you guys. Some people know this, and I think it's okay to say because I am now dropped out. I used to work with metals when I was studying, okay? And we would also melt the metals sometimes, right? We would melt the metals in like some sort of special oven, and then we would pour it into, different shapes and stuff. And looking back, like, that was the scariest thing. Because if you think about it, how hard it was, if you think about that, and like all you would wear is like some gloves, and I mean obviously like an apron and safety glasses, but that's all you get. And while it's like, over 1,000 degrees Celsius plus. Yeah, kind of insane. Still not as hot as a snail, girl. What?
Alright, let's melt some titanium.
I didn't work with titanium though. I have melted copper and bronze and silver. Yeah. You can take your guesses at what kind of school it was. I feel like it's not that hard to guess. It was very fun.
Man, I'm gonna be seeing spots for a long time. That was so bright. Oh my goodness. Oh my
God. Dude, the sound is crazy. crazy. Is that where the saying "you sound like you're in a microwave" is from? Nice.
I'm running out of metals with higher melting points. So this time I'm going to try making rubies, based on a cool video by Nighthawk and Light. Okay, so I ran into a lot of issues with this one.
What?
It was mostly due to stupidity on my part. The gist of this procedure is that you use a microwave plasma to melt an alumina-chromium mix, which yields ruby. However, for some reason, I thought Ben's procedure generated the alumina via an exotic thermite reaction between chromia and metallic aluminum. This false assumption led to a lot of broken glass and several failed shots. The funny part is that my chromia thermite still ignited with ease, which is probably even harder to pull off than making ruby. However, when I used alumina like I was supposed to, I still ran into issues.
Oh.
The plasma escaped and the glass container exploded after just a couple seconds. Fortunately, this was still enough time to finally make some ruby. Thank goodness.
Yippee! He made it! Ruby's very cool. I feel like ruby is one of my favorite gems. Ruby, and what else is very cool? Amethyst and emeralds. Those are very cool.
You know, the fact that this can
But I feel like I like ruby the most. I don't know why. Red is not even my favorite color, but I don't know. I like it.
done in a normal oven means I really haven't hit an impressive temperature yet. So, let's cut the fluff and move to something extreme. It's time for the metal with the highest melting point, tungsten. The melting point of this is literally
Tungsten cube mention! Oh my god. Tungsten mention.
thousands of degrees above anything else I've tried so far. So this one might be challenging.
Isn't it expensive? Oh my god.
For whatever reason, the plasma in this beaker kept escaping confinement, so I couldn't give it a long enough zap. The wire may have burned a bit in there, but there wasn't any clear indication of melting, so I decided to give it another go on ceramic fiber. Heck. Oops! Waveguide flashover. It turns out, free plasma in the oven is really bad.
Sharpie? Is that the Reddit gem again that you just added? You guys.
Because it jumps back to the magnetron through the waveguide. I used these mica waveguide covers, which buy about a half a second of plasma escapes, but this one got all crispy without me realizing it. It won't take many flashovers like this to destroy the oven.
Oh my god.
And unfortunately, this is not the first time this has happened either. Alright, here we go.
Oh no.
Heck. Alright, we got a new waveguide cover. Let's try this again.
Okay, well thank god he just has a replacement, I guess. Wait, what the heck? What? Oh!
That run clearly melted some of the tungsten, as you can see by the beading on the wire. Now that is impressive. So this macrowave is capable of melting any metal. But the thing is, I'd bet that plasma in there is substantially hotter than even tungsten's melting point. Unfortunately, there's nothing tougher that I can melt, so I can only say it's at least 3,422 degrees C.
I mean, yeah, I'm surprised how well the camera can hold up, generally. Because the camera is just a normal phone. But it's not, it's not bad. It's not going bad.
Now, something that I found is that although tungsten is the toughest metal I can throw in there, it's far from the most interesting. So to get to the point, what happens if I microwave a lithium battery? Well, embarrassingly, I couldn't get one to pop. The oven itself would flash over before anything happened to the battery. I tried cheating by using some steel wool to initiate a plasma.
What?
But even then, the plasma refused to stay contained. So, I decided on a different approach.
Oh no.
I carefully opened one up and extracted the lithium foil inside. Microwaving this foil gave a surprising result.
Guys, have you ever Okay, this is one of the essential, maybe a little bit silly questions, but have you guys ever licked a battery? Yeah, carefully. What is he doing? Of course, no. Yes. Okay. Yes. Okay, most of you have. But I was a bit worried always because like I always thought they were like I always thought it was like dangerous, but then at the same time when I was a kid, I did like the taste of the battery. But I don't think you should do it because they can leak and stuff. If you're worried, then don't do it. I was a stupid child, okay? I was a stupid child. I also bit on a glow stick once until it exploded, and then on all the liquid like ran out. So that is that, okay? That is that. It's the easiest way to check if there's still juice in a 9-volt battery. Wait, does it not taste at all? Wait, you guys are actually doing... Wait, it's actually like a thing? See, I was just being a smart kid. I was just being a smart kid, you guys. Yeah, that's probably more dangerous. I think so too. The glow-in-the-dark stick, ooh. You glow in the dark now? I'm not sure. Maybe in some places. You know, I can't look in my own face when I'm... Anyway. Sure, let's say that. I was saying. Oh my god. Is it okay?
Incredible red coloring is due to lithium's atomic emission spectrum. What I expected to see was maybe a few red flashes in an otherwise white plasma, simply because the temperatures are so high. The fact that the colorful spectral lines were favored opens up the possibility of all sorts of colorful plasmas.
It's so pretty! Oh.
Now this brings up the question, what happens if I start chucking a bunch of weird chemicals and metals in there? Can I make a full rainbow of plasmas, at least to a Roy G. Biv approximation? Well, there's only one way to find out. For the next weird metal, let's try a lump of calcium. This sample is surprisingly still shiny, even though I've had...
Wait, this is calcium? This is what's in the milk? I've never seen chunks of calcium. What? What? It's a metal? I did not know that. Yeah, and in my bones? What? What? I have in my teeth as well. I have metal in my body.
For years. I'm hoping it'll show off its orange spectral lines when yeeted into a plasma.
I mean, to be fair, I know that I have iron in my blood as well, right? I mean, I don't, but I should have iron in my blood. But I didn't know about the calcium. What the heck? Did you do chemistry? I did. But holy shit. Oh my god. Oh, pretty. It's pretty. Is this what's gonna happen if I set my bones on fire?
Well, that was easy, and stupidly bright as well. On to the next one.
Yay!
For yellow, I'm gonna zap some sodium metal. For reasons I'll get into
He just
soon,
cuts it.
zapping the angry and highly reactive metallic form is a totally unnecessary way to see the sodium spectral colors.
Yeah, I think I've seen zinc and magnesium, but I knew that those were metals. I didn't know that calcium looked like that. I don't know. I guess it's because, you know, all I hear about calcium is that it's in my bones and in the milk. So I always imagine more like a white substance, right? Like bones kinda, but or like chalk kinda. That's how I imagined calcium. But I was wrong. I was just wrong. Holy shit.
However, for the sake of memes, I'm gonna do it anyway.
For the sake of
I
memes.
do need to address something first, though. The last time I pulled out this lump of sodium, so many of you freaked out over the quantity.
Wait,
Now let me
really?
tell you a little something. This little chunk right here is nothing. In fact, when I was 13 years old, I obtained 2 400-pound barrels of metallic sodium.
I have so many questions. I have so many questions.
Now that's a story for a different day.
Well, no, I want to know, please. At 13? How?
But be assured, this ain't much. Well, anyway, eat.
Oh my god.
I want to point out that this exact yellow color has shown up in this video several times already, and in particular, all the times that glass has broken into plasma. This is because sodium in the glass is coloring the plasma.
Ooh.
Now, Nile Red actually has an entire video on this very effect.
Ooh.
It turns out, it only takes a little bit of sodium to make a lot of yellow light. And this can be a blessing or a curse depending on what you're trying to do. With yellow down, let's move on to green. I'm mixing up some trimethyl borate, which will hopefully show off boron's spectral colors. Since this isn't conductive on its own, I'm using a sliver of aluminum wool to initiate it. It's funny because the free boron must have been thousands of times more concentrated
Oh,
than
the
sodium
green
in
is
there.
cool.
Yet it's the sodium yellow that stuck out at first.
Whoa!
Eventually, the boron won out though.
Yeah, this is what I think of when I hear the word plasma. Holy shit. Does that mean MIP is sodium based? I mean, I guess I have sodium in my body, so I guess you could say that.
Making a nice green color.
So good. So good.
Well, green was easy enough, so how hard can blue be? I figured copper would be the element to zap, but then I remembered that when I melted it, it didn't make much blue light. But that's the thing about copper. It has to be tickled in just the right way before it'll spit out blue light. And this is why blue is such a challenge in fireworks. So, I tried a pyrotechnics trick.
Oh, welcome home, Digressor!
And added a source of chlorine in the form of copper chloride.
Yay!
This one sucked. I was hoping for blue emission from hot molecular copper chloride.
It looked so cool. Look at that. What the
Form of
fuck?
copper chloride.
Damn.
This one sucked. I was hoping for blue emission from hot molecular copper chloride.
It does have
But this
some
really
blue.
only made a little bit of blue. Maybe the plasma was too hot in there. I don't know. Let's try something else.
It's so bad. It's so bad.
Microplastics. Maybe this will provide a better form of chlorine for the copper.
Oh my god.
There were a few good flashes of blue in there, but still not what I wanted. Maybe I just need to change metals.
I read 6-7. I just wanted to say that real quick because my brain is fried.
I carefully opened up a lantern battery to extract the zinc metal casings.
Jesus.
And what do you know? Sodium yellow.
Yay.
I even tried a strip of high purity zinc, and although this one briefly flashed blue, it was still the trace sodium contamination that stole the show.
Okay, that's really cool. Purple and yellow.
Yellow chemistry at its finest.
Ooh.
Embarrassingly, the bluest plasma I've gotten so far was actually just the aluminum foil I zapped earlier. Out of desperation, I decided to try this again in a bigger beaker, with the hopes that the higher volume would lower plasma density and favor atomic emission.
Ooh! Wow, pretty! What the heck? It's not even melting all of it. What the fuck?
Wow. All of those fancy chemicals and elements, only to be outperformed by a strip of aluminum.
Dude, this looks like magic. Like when a wizard does like magic things, this is what he makes. You know what I mean? It's just this looks like pure magic ball, but it's science.
Wow. All of those fancy chemicals and elements, only to be outperformed by a strip of aluminum foil. Chemistry is stupid. With blue finally down, it's time to take on indigo. And there's no better metal for indigo than indium.
Oh, I like indigo.
It's no coincidence they sound so similar, because indium was actually named after the color indigo. Why this is becomes very apparent when indium is zapped by my demon circuit.
Does he have every metal? Does he own every metal? Does he own uranium as well?
Makes more indigo light than I've ever seen in my life.
Whoa.
Can the same be done with a macrowave? Let's plasmify some
That's so
indium wire
cool.
and find out. Blue? Ah! I tried so hard to get blue earlier, and now it shows up when I don't want it. Figures.
He's so angry.
Instead of indium wire, I melted some of the metal in the bottom of a beaker, hoping that it would provide more metal to the plasma.
Glory crisis
Nope,
is no,
still
I
blue.
guess.
In hindsight, the ceramic fiber base was probably poisoning the color there, but I didn't consider that before trying the next experiment. I added some indium chloride, hoping either the chlorine or pre-ionized indium would change the color. This was a big improvement, and although the plasma was a bit obscured by the smoke, I would have probably stopped here if it wasn't for the next experiment. As a side note, I should mention that while indium metal is essentially non-toxic, indium smoke is really bad to breathe in, as is ceramic fiber dust. These are...
That's crazy. Thank you for letting me know. Thank you for letting me know, Mr. Styropyro. When I try this at home, I'm gonna remember.
one of many reasons I'm wearing a respirator.
Yeah, right? The metal is so chewy. It's like, it looks like, you know, cheese. From the chewiness.
Anyway, I decided to try macrowaving some gallium crystals. Most people know gallium for its very low melting temperature, but it turns out it has a beautiful emission spectrum as well. Some crystals in the bottom of a beaker were enough to give some interesting colors, and flipping the beaker over really brought out the color.
Wow!
And what do you know? There's the last of the colors, violet. I didn't stop there though. I was curious what would happen if I made an alloy.
Real, like, what, how do you say it? Light show. Natural light show, except it's not natural, but, yeah. Bye-bye, Sean. Bye-bye. Wait. Yeah. Take care.
I didn't stop
Look at that.
there though. I was curious what would happen if I made an alloy
Real
of
life
gallium and
light
indium.
show. Not real life. Anyway. I guess it's a light show with extra steps. Or Aurora Borealis. It is. But I mean, it's not the same, but you know, yeah.
I didn't stop there though. I was curious what would happen if I made an alloy of gallium and indium, and then zapped that. Sure enough, a nice clear indigo started to come through.
Ooh,
After playing with ratios and settling on an alloy that was mostly indium, I created my favorite plasma of this entire project.
Oh my god, it's so loud. But that's pretty. I love it. I love this kind of color. My favorite kind of color is the bluish, purplish.
Holy! Wow!
Holy moly!
Wow! That was perfect! That was beautiful! Yes! Yes! Ah, that was perfect! Oh, so beautiful! I'm sorry.
Yeah, he's so expressive.
I've made every color I wanted to and melted every element I wanted to. And I don't even want to stop here.
That's crazy, man. He's so hyped when he does that, and then when he exploded the egg, he was like, that was fun.
However, this video is getting pretty long. There's still so much more I want to do with
What
my
the
huge
fuck?
magnetrons. I even made this cool Faraday helmet for some of my more cursed ideas. I should probably save those experiments for a separate video, just because I don't want to rush through them. Instead, let me try to address some questions that I just know you guys will ask about otherwise.
Yeah, I guess it's his helmet, but what the fuck?
What does it do to electronics?
Uh-oh.
Well, most things I threw in there gave the same result. RAM sticks, plasma.
I mean, it makes sense because they just include the metals that he already melted.
Neon bulbs, plasma. PCBs,
Oh my god.
plasma. Christmas lights,
My RAM, you guys! He just burned it! Can you believe it? Oh no. Imagine him doing that today. Oh god. Yeah, R.I.P. $2,000. Oh no.
Some funny colors, but mostly plasma. The only electronic device that didn't ionize was this broken calculator.
He didn't know. He didn't know what would happen to the RAM prices soon.
Plasma. The only electronic device that didn't ionize was this broken calculator. But the smoke it made was essentially a chemical war crime. I tried
Ooh.
CDs as well, but their coatings vaporized in a fraction of a second.
Whoa,
So, what
that's
about the
cool.
health risks of this contraption? Well, the real risk here isn't microwaves, it's the power supply. Now, put simply, you touch any of this stuff while it's live, you'll die instantly.
What?
But as for the tiny bit of
He just has that in his house? What? No way. No way. Wait, I mean, I guess. But that's so scary.
microwaves that escape the oven, those are harmless for
Holy
the same reason your
shit.
Wi-Fi router is harmless. And that's because microwaves are non-ionizing radiation.
Oh
Hold
my
up.
god.
Microwaves are non-ionizing radiation? Didn't I just spend the entire video ionizing stuff with microwaves? Yes. So let me explain by briefly talking about radiation. Now this word scares a lot of people because they associate it with scary forms that cause cancer. But not all radiation is this way.
Yeah, I mean, microwave works by radiation, right? Thank you, Crazy, for the 20 Steam streak. Thank you very much. Anyone trying to rob this guy gonna fry instantly. It's a good thing to have for self-defense.
Microwaves are a type of electromagnetic radiation.
Yeah.
This type of radiation includes scary stuff like X-rays, as well as just light.
Whoa, wait. Microwave? Infrared, visible, ultraviolet? Okay. Frequency. I guess, like... Wait, where does it start to get dangerous? I know UV light. UV light is like... UV light can be bad, right? If you get too much. Because of, sun bad. And then... Is visible already? Is visible? Is infrared bad? Yeah, UV can give sunburns and cancer. Yeah. What about the visible?
This does not include particle radiation, like you get from
UV
some
light
kinds
is
of
like the
radioactive
sun.
decay.
Sorry, did you see that?
Now this is where things get confusing. Ionizing radiation includes high-energy EM stuff,
Okay, it is all of these that are dangerous. All right.
as well as particle radiation, and nuclear radiation falls here as well, but not all ionizing EM radiation is nuclear radiation, if that makes sense.
Yeah.
Okay, all that considered, you may have heard that light has properties of both a particle and a wave, right?
Hello, night.
Well, this is where the distinction of ionizing comes in. Ionizing EM radiation is where one light particle, or photon, has enough energy to strip an electron off of an atom and ionize it. Photons with this energy can mutate DNA, leading to cancer. A microwave photon is literally 1,000,000 times weaker than this threshold.
Whoa!
Now, to be fair, a photon doesn't have to be quite at ionizing energy to be
Oh my God.
cancer-causing. As
The marshmallows! What? I want to see more of the marshmallows, please. What the heck? Oh god, that must have been awful to clean afterwards. Oh my goodness.
UV can still cause damaging photochemical reactions to DNA.
Oh my god, another children's story time. I used to have like a teddy bear, and you could on his tummy you could draw with like a UV pen. Yeah.
But even this is 100,000 times more
Like
energetic
that.
than microwaves. Then how do microwaves ionize stuff? So bear with me. I've already mentioned that microwaves are electromagnetic, which means they have an associated electric and magnetic field. Now, it's the electric field that's relevant here, and an important property about these fields is that they add up. That means that when you put enough microwaves in a small enough space, the electric field grows to the point where it can rip apart atoms and molecules on its own. This effect is not exclusive to microwaves, and even visible light will ionize air if there's enough of it.
my
Sticking
god.
your hand in the oven won't shoot a bunch of holes in your DNA and give you cancer. It will simply cook it like you dunked it in lava.
Oh my god. Oh, the balloon. The balloon gives me so much anxiety. But it wasn't actually that loud, so it's okay.
Of course, burns only happen at huge powers. At low power, like what leaks through the oven door, those risks simply aren't there. Oh, and for the record, I did measure the microwave leakage from this. And it's so small that it's well within the legal safety limits of what's allowed to be sold for home use.
So is he saying this microwave should be sold for anyone to use? What? It leaks more than the microwave. I leaked one. No, I didn't leak anything today.
It's incredibly well sealed.
Oh!
Other than one mishap where the tape
poor
on the door
Sharpie.
exploded and EMP'd one of my cameras. But we don't need to worry about that. So hopefully that convinced you that microwaves are safe in small amounts. Because on an unrelated note, I now have to give you an update on my health issues.
The way he smiles. Why is he saying that? What the fuck?
Now before I end this video, I think I'm obligated to give you some updates on what I brought up in my last video. As a recap, I recently found out that I have just like bonkers testosterone levels, and this is concerning because I also have had these unexplained markers for liver disease going back more than 10 years.
Oh no.
Well, since posting that video, I went through the medical ringer. I got poked and irradiated and fondled in about like every way you can imagine. And no actual disease was identified, although they still found a little bit of liver scarring on the liver biopsy. Now, even though I don't know what's wrong, this is still a pretty good result because it means that, well, it rules out a bunch of nasty diseases, but also means that whatever is wrong doesn't seem to be progressing very quickly. Now, if something changes, or if by some chance I actually solve this mystery, I'll be sure to let you guys know. Now, many of you brought up that I may have caused these issues due to all my experiments. And of course, I can't help but wonder that as well. I mean, maybe it shouldn't be a surprise that somebody that does what I do has, weird and unexplained disease. But you know what? I know it wasn't microwaves that caused it, or anything high voltage like Tesla coils, because I've had these disease markers since before I ever messed with that kind of stuff.
Well, at least he knows he can continue doing what he loves.
Now, chemicals, or I guess technically lasers for some reason, I mean, yeah, it's possible. I like to think I've been pretty careful to limit exposures, but then again, I've been doing that stuff my whole life, so it's possible that some, small exposures added up to something. But I wonder about the reverse possibility as well. I never had my testosterone levels measured before this year, but because I don't have any symptoms of like hormone changes, there's a good chance they've always been that way. And assuming that is true, then I wonder how much of a role did that play in my extreme hobbies?
Sorry. Cat! Katie! So cute! Oh my god, I just noticed!
And assuming that is true, then I wonder how much of a role did that play in my extreme hobbies? I mean, basically every activity I enjoy is dangerous, and it's been that way since I was a preteen. And considering the associations of testosterone with risk-seeking behavior, I feel like, bonkers hormone levels to start with might explain some things. So yeah, whether I caused my crazy body chemistry or whether crazy body chemistry caused me, I feel like both are about as equally likely. So that's about all I have for you today.
Oh.
So until the next time.
You guys, I was gonna say bobel, but this is not a bobel. This is a squirrel.
Stay safe and happy microwaving.
But goofy, silly. I can't believe it. He just has all of that at home. But yeah, alright. I hope you enjoyed. If you did, like and subscribe to styropyro, and check out his videos. And I'll see you in the next one. Bye, YouTube. Bye-bye.